All right, welcome back. We are going to continue talking about ratios and scale factors, and we're going to be talking about specifically scale factors this time, which are a little bit different than the ratios that we've been working with before. Excuse me. So recall again that we have ratios. Let me find a color that I like, and they compare two quantities, 3 to 4. And then we discovered that we also had proportions. And they set things equal to each other. 3 to 4 is equal to 6 to 8. And then we've decided that we can have our unit rates. And that is really just a rate where one of them is equal to 1. So if I say 55 miles per hour, that 1 hour is on the bottom, so it works out. And we were having unit scales before, and that's what we were just talking about, unit scales. And that was saying that, like, if we have our scale to actual, we often have like 1 inch is 100 miles. Today, though, we're going to be talking about scale factors. And the difference between a scale factor and a unit rate is a scale factor does not have any units at all. For example, there is a very popular scale factor relating to model trains. Trains are super popular, but you can't collect trains because they're giant. So when they build model trains, they build them what's called is, well, there's a lot of different scale factors to use, but the smallest one is called N-gauge. You spell gauge right, G-A-U-G-E. And that means that all the little train cars, let's build a little caboose. Well, my caboose is terrible. Don't judge it. Just trying to caboose, important caboosey things to do. And you can't collect these because they're really big. But a smaller one is built to the scale of 1 to 160. That means the trail car, the little car that you can buy, is like this big, and it's 1/160th of the actual size of the car. And then you can build little models of them and like drive them all over your house, and they're really, really cool. But they're based on this scale factor, which does not have any units. And that's going to be the key today. Pretty much everything else is exactly the same that we have been doing. Let's take an example using these N-gauge trains. So someone just built often when you build these little train setups, you get like a piece of plywood or something, and then on it you build your little tracks going all over the place. I'm going to make my little track. I think the train would probably derail if it was on this track because it's terrible. But it's okay. No one's riding it. Just pretend people. And here's my beautiful tree. Okay, perfect. My model's done. And the question is, if I have my model and it is 4 feet by 8 feet, what size of land does this actually represent if it's all built to the N-gauge? And when they do this, they build the rails, they build the trees, they build the tunnels, all the houses. Everything is to this 1 to 160th. And it's really easy to see. We're going to call this our height. I'm going to call this my length. And I need to solve one for each. So I have my length and my height. So for my length, we'll do that one first. I'm just going to write my scale to actual. So my scale here is 1, and my actual is 160. And then I'm going to write my scale here is, I have 8 feet, and my actual is what I'm trying to find out, right? What's nice is when I cross multiply using the scale factor, I always get just x by itself on one side. So it saves me a step. And that's why we typically use the scale factor instead of unit scale when we're building things to scale. Simply because mathematicians are lazy and we like to do as little steps as possible. So, quick cross multiply. You can see my x multiplies by 1. So I have x times 1, if I want to write that, I don't have to, equals 8 feet times 160. Well, I know what x times 1 is. I don't need my calculator for that. But I'm going to go ahead and do 8 times 160 equals, we saw that, 1,280 feet, which is what my unit is currently in. So this I know is equal to my L. So my length represents 1,280 feet. I'm going to do the same thing for my height. Now I could see a little trick here. I know that 4 and 8, they're proportionate to each other. If I did the 8, the other one should be half. So I'm going to guess that it's going to be what? 640 feet, because I can divide that in half. But I'm going to go through the math anyway, just to make sure that I did it right. So again, I'm going to remind myself that I'm always going to do scale to actual. And I'm going to write it out. My scale here is 1 to 160 equals 4 feet to x. Cross multiply. And I have x equals 4 times, 4 feet, I should have said, times 160. And then I can check 4 times 160 is, unsurprisingly, 640. Which means that my height, sorry, I almost wrote width, is 640 feet. So this little train track here represents 1,280 feet, which is about probably around 1/5 of a mile by 1/10 of a mile. So a fairly large area that I can build with my little train. Now, if you feel like you understand what I'm talking about, feel free to go on to the questions. They're going to reference this and unit rates and everything that we've been learning. But I will do another example or two if you'd like to see how more are done. Okay, let's do and talk about example 2. Okay, we're building a model airplane. And the actual airplane has a wingspan of 16 feet. Our scale factor for our model is 1 over 48. Remember, I can write it like that if I want. I can write it like that. I can write it all sorts of different ways. The question is, what's the wingspan of the model? All right, so I'm going to go, let me check. I'm going to do scale to actual, which means I'm going to do 1 to 48 equals, let's see, I know my actual wingspan, so I'm going to put my actual underneath. And my question is, what is my scale going to be here? I'm going to cross multiply, which gives me 16 times 1 equals 48x. Now, this time I don't get x by itself. I shouldn't have said what I said earlier, because if I'm working for my scale, I will have to multiply it out. But that's easy, because all I have to do here is divide. So I can divide this side by 48, this side by 48. These 48s go away, which ends me with 16 divided by 48, which is 1/3. So that means that my wingspan here is going to be, let's see, 1/3 of a foot. And if I wanted to write that into inches, I know that there are 12 inches in 1 foot. So I can see 4, 8, 12 if I divide my little ruler up into 3 sections. Then I could also write this as 4 inches. That's part of the issue of why I hate doing things in feet and inches, just because it's like another mental step to have to switch it back to what it's supposed to be. But either of these answers would be perfectly fine. They would get to the same actual measurement. All right, does that make sense? I'm going to do one more if you'd like to see how it works. Okay, we're going to, oops, almost dropped it. Example 3. This time, we're going to be looking at a carpet. Carpet is 4 inches by 2 inches. Oh no, this is our scale drawing, sorry. And the scale factor is 1 to 24. And what is the actual carpet, okay? So I'm going to kind of use my little trick, and I notice that 2 and 4 are related because 2 is just times 2. I can get it to 4. So I'm just going to solve for this one, and I'm going to double it because that sounds way easier to me. So I'm going to go scale is to actual, which gives me 1 to 24 equals, my scale is 2 inches. And I don't know what my ending is. So that gives me x equals 2 inches times 24, which gives me 48 inches. So I could leave it as 48 inches, or I also know that this, if I divide it by 12, it's going to give me 4. So it's going to give me 4 feet. So my height here, my width, my height is 4 feet because I solve this, and then I know this ratio is just times 2, so my width is going to be 8 feet. Oh, and I've been forgetting to put boxes around everything, just like usual. Sorry about that. Oops, that's not what I was supposed to put. This was the answer for the previous one. Makes sense? I hope so. If you're still confused, find someone to ask and we'll do our best to help you.